Yellowstone National Park, a place where the wonders of nature are on full display, offering a glimpse into the Earth's most awe-inspiring landscapes. It is a land of majestic beauty, where towering mountains and expansive valleys create a breathtaking panorama. The park's diverse ecosystems are home to a variety of wildlife and plant species, making it a haven for nature enthusiasts and scientists alike. Towering geysers erupt with scalding water, shooting high into the sky in a spectacular display of geothermal power. Old Faithful, the most famous of these geysers, has been captivating visitors for generations with its predictable eruptions. Colorful hot springs shimmer in the sunlight, their vibrant hues created by heat-loving microorganisms. These geothermal pools are not only beautiful, but also provide a unique window into the Earth's geothermal processes. Bison and elk roam across vast meadows, grazing peacefully in the shadow of the park's towering peaks. These iconic animals are a testament to the park's rich biodiversity and the successful conservation efforts that have helped preserve their habitats. But beneath this serene beauty lies a secret, a hidden force that has shaped the landscape over millennia and continues to influence it today. A powerful force sleeps below. The geothermal activity that powers the park's geysers and hot springs is a reminder of the immense energy stored beneath the Earth's crust. Yellowstone sits atop a supervolcano, one of the largest active volcanic systems in the world. The caldera, a massive volcanic depression, is a testament to the park's explosive past. This is a volcano capable of eruptions thousands of times larger than normal volcanoes. Such an eruption would have global consequences, affecting climate and ecosystems far beyond the park's boundaries. The last major eruption at Yellowstone occurred over 600,000 years ago. This cataclysmic event reshaped the landscape and left a lasting mark on the geological history of the region. It was a cataclysmic event, sending ash clouds high into the atmosphere and covering vast areas with volcanic debris. The impact of such an eruption would be felt around the world. The park's unique features are a direct result of this volcanic activity. The geothermal wonders that draw millions of visitors each year are a testament to the dynamic forces at work beneath the surface. Heat from the molten rock below powers the geysers and hot springs, creating a landscape that is both beautiful and otherworldly. The steam rising from the ground is a constant reminder of the energy that lies beneath. The vast caldera, a volcanic depression, is a testament to past eruptions. It serves as a reminder of the park's explosive history and the potential for future volcanic activity. Yellowstone is a reminder of the awesome power of nature. It is a place where the forces of the Earth are on full display, offering a glimpse into the planet's dynamic processes. It is a place where beauty and danger coexist, where the serene landscapes hide a powerful force beneath. Yellowstone National Park is truly a park like no other. The ground beneath Yellowstone is restless. It rises and falls over time. Scientists call this phenomenon ground deformation. Think of it like the Earth breathing. Land uplift occurs when magma, molten rock beneath the surface, pushes upward. Pressure builds. The ground swells like a giant balloon. This movement is subtle, often just a few inches per year, but it is a sign that the supervolcano is alive. Scientists use sensitive instruments to track this movement. GPS stations and satellites measure even tiny changes in elevation. This data helps us understand the forces at work beneath Yellowstone. It also helps us predict future volcanic activity. Yellowstone's history is marked by eruptions of immense scale. These eruptions have not only shaped the landscape but have also influenced the climate and ecosystems around the region. The sheer power of these volcanic events is a testament to the dynamic nature of our planet. These events have reshaped the landscape, carving out valleys, forming mountains, and creating vast plains of volcanic rock. The transformation is evident when comparing the pre-eruption and post-eruption landscapes. They have left their mark on the planet, with volcanic rock formations and ash deposits that tell the story of these ancient cataclysms. These geological features are like pages in a history book, revealing the violent past of Yellowstone. There have been 3 major eruptions in Yellowstone's past, each one more powerful than the last. These eruptions are key events in the geological timeline of the region. The first, 2.1 million years ago, was the largest. This colossal eruption ejected an unimaginable amount of volcanic material into the atmosphere. It ejected over 2,500 cubic kilometers of volcanic material, creating a massive ash cloud that would have darkened skies for miles around. This eruption created the Huckleberry Ridge Tuff, a vast deposit of volcanic rock that stretches across the landscape. The Huckleberry Ridge Tuff is a significant geological feature that provides insight into the scale of this eruption. The second major eruption occurred 1.3 million years ago. Though smaller than the first, it was still a monumental event in the history of Yellowstone. It was smaller but still massive, releasing a significant amount of volcanic material and reshaping the landscape once again. It formed the Mesa Falls Tuff, another extensive deposit of volcanic rock that adds to the complex geological history of the region. The most recent major eruption, 630,000 years ago, created the Yellowstone caldera. This caldera is a massive volcanic crater that dominates the landscape of Yellowstone National Park. These eruptions were not isolated events. They were part of a series of volcanic activities that have occurred over millions of years. Smaller eruptions and lava flows have occurred in between, contributing to the ever-changing landscape of Yellowstone. These smaller events, while less dramatic, are still significant in shaping the region. Yellowstone's volcanic activity is a continuous process. The geothermal features we see today, such as geysers and hot springs, are a direct result of this ongoing volcanic activity. It has shaped the park we see today, creating a unique and dynamic landscape that attracts millions of visitors each year. The story of Yellowstone's eruptions is a reminder of the powerful forces that continue to shape our planet. The term supervolcano evokes images of apocalyptic destruction, and for good reason. These colossal forces of nature have the potential to alter the course of history in a single cataclysmic event. When they erupt, they can unleash devastation on a scale that is hard to comprehend. Yellowstone's past eruptions have been devastating. The last major eruption occurred over 640,000 years ago, and it left a caldera that spans over 30 miles. The sheer magnitude of these eruptions is a testament to the power that lies beneath the surface. But what exactly makes it a supervolcano? It's not just the size of the volcano itself, but the scale of its potential eruptions. Supervolcanoes are not defined by their size. Instead, they are categorized by the sheer volume of material they can erupt. This volume is what sets them apart from regular volcanoes. They are categorized by the sheer volume of material they can erupt. To be classified as a supervolcano, an eruption must eject at least 1,000 cubic kilometers of material. A supervolcano eruption must eject at least 1,000 cubic kilometers of material. This is enough to cover entire regions in a thick layer of ash, affecting climate and ecosystems worldwide. That's enough to bury a large city under hundreds of meters of ash. Imagine entire cities disappearing under a blanket of volcanic debris, altering landscapes and lives forever. The source of Yellowstone's power lies deep underground. Beneath the picturesque landscapes and geothermal wonders, there is a hidden force that drives the park's unique features. A massive magma chamber, a reservoir of molten rock, fuels the volcano. This chamber is a vast underground pool of molten rock, constantly feeding the geothermal activity above. This chamber is estimated to be 50 kilometers long and 20 kilometers wide. It's an immense underground structure that holds the key to understanding Yellowstone's volcanic potential. The heat from this magma chamber drives the park's geothermal features. Geysers, hot springs, and boiling mud pots are all surface expressions of the intense heat below. It is a constant reminder of the immense power that lies beneath our feet. Yellowstone's geothermal wonders are not just natural attractions, they are windows into the powerful forces that shape our planet. Section 5. Measuring the magma. How scientists monitor Yellowstone. Yellowstone is one of the most closely monitored volcanoes on Earth. Scientists use a variety of tools to keep watch over this sleeping giant. Seismographs detect earthquakes, which can be caused by magma movement. GPS stations track ground deformation. Gas sensors measure the release of volcanic gases like sulfur dioxide. These instruments provide a constant stream of data. Scientists analyze this data to look for changes that might signal an impending eruption. They also use computer models to simulate different eruption scenarios. The goal is to understand the behavior of the volcano. With more knowledge, we can better prepare for future eruptions. Early warning systems could save lives. Section 6. The big one. Assessing the risk of a future eruption. Will Yellowstone erupt again? The answer is almost certainly yes, but when? That is the million-dollar question. Scientists agree that a major eruption at Yellowstone is not imminent. The magma chamber is not currently in a state that would suggest an eruption is likely anytime soon. However, volcanoes are complex systems. Predicting their behavior with absolute certainty is impossible. there is always a chance of an unexpected eruption. The United States Geological Survey, or USGS, constantly assesses the risk of a Yellowstone eruption. They use the latest scientific data to provide the public with accurate information. Section 7. Global impact, the potential consequences of an eruption. A supervolcano eruption at Yellowstone would be a global event. Its effects would be felt far beyond the borders of the park. The immediate impact would be devastating. Pyroclastic flows, fast-moving currents of hot gas and ash would incinerate everything in their path. Ash would blanket the surrounding states, collapsing buildings and disrupting transportation. The long-term effects would be equally severe. Volcanic ash in the atmosphere would block sunlight, causing global temperatures to plummet. This volcanic winter could last for years, disrupting agriculture and causing widespread famine. The economic and social consequences of a supervolcano eruption are difficult to comprehend. It would be a disaster of unprecedented scale. Section 8. Living with Uncertainty, the Future of Yellowstone. We live in a world shaped by powerful forces: volcanoes, earthquakes, hurricanes. These are reminders of nature's raw power. We cannot control these forces, but we can understand them. Yellowstone is a source of both wonder and worry. It is a place of immense beauty shaped by violence. We are drawn to its beauty, even as we acknowledge its potential for destruction. The key to living with uncertainty is knowledge. By studying Yellowstone, we learn about the forces that shape our planet. We gain a deeper appreciation for the power of nature, and we can better prepare for the future. Section 9. Yellowstone Forever, a legacy of awe and wonder. Yellowstone National Park is a national treasure. It is a place of wonder, beauty, and scientific importance. It is also a reminder of the awesome power of nature. The land above Yellowstone is rising. This is a sign that the supervolcano is alive, but it is not necessarily a cause for alarm. Yellowstone is constantly changing. It is a dynamic system. We must respect the power of Yellowstone. We must also appreciate its beauty. This park is a gift. It is a legacy we must preserve for future generations. Let us marvel at its wonders. Let us learn from its secrets. And let us continue to explore the universe we inhabit.